All right, so in this video, we want to find the domain and range of these functions over here. I'm going to do sketches of the functions as well. It's not necessary, but I like to do sketches because it also gives you a bit of extra knowledge as well. So let's take a look at this first question over here. We know that this first function over here is a linear function. The y-intercept is positive 8, and the slope is negative 3. So it looks approximately like that. And you can tell that the domain is all real numbers because as we go towards the left, it goes towards negative infinity. As we go towards the right, it goes to positive infinity. So there are no restrictions. And my range is also all real numbers because when I'm looking down, it goes towards negative infinity. And when I look up, it goes towards positive infinity. So no restrictions on y as well. And that's basically a domain and range for pretty much almost all linear relations. Let's take a look at the second question. We have a quadratic relation over here. My x value of my vertex is -3 and my y value is +4. And my a value is negative, which means that it opens down. So the graph looks like this, -3, 4. My domain, I'm going towards the left, towards negative infinity, towards the right, towards positive infinity. So my domain is all real numbers. And my range, my highest possible y value is +4. So my range is y is an element of all real numbers such that y is less than equal to 4 because y basically takes any value below 4 or equal to 4 on this graph. Third one over here is a square root graph. X value of my starting point is +1 and there's no C value here, so the Y1 value will be 0. So 1, 0 over here. There are no reflections over here in this, so it's just going to go into the regular direction of a square root graph right there. And if I do the domain of this graph, my lowest X value is +1 and my highest X value is infinity going towards the right. So it's just X is greater than equal to 1. For my range, the lowest y value is this point here, which is a y value of 0. Highest y value is also positive infinity, which means y is greater than or equal to 0. And let's do these three for a bit of extra practice. First one over here is quadratic. Vertex x value is +2, y value is -5, so +2 and -5 is down here. A value is positive, so it opens up. And my domain for pretty much all quadratic relations is all real numbers because left and right go towards infinity. My range, my lowest value, my lowest y value in this graph is -5. Every value y takes is above that. So it's going to be y is greater than or equal to -5. Fifth one here, this is a linear relation. Again, we don't need the graph, but I'll do it really quick. This is a linear relation that's not in order. So that's my y-intercept right there, which is +11. And this is my slope, which is -5/2. So negative slope. The graph looks approximately like this. And your domain and range are just all real numbers. Like I said, that's pretty much true for almost all linear relations, at least all diagonal ones. And the last question here, again, is a square root function, but again, we can tell this is out of order. And this is a trick question, very, very common on tests, and you definitely want to know how to solve this going into your test. So before we do a sketch, we're going to actually rearrange this. We're going to move the 5 towards the end, so it's -x plus 5. Nothing has changed over here. Now I have a k value and I have a d value in terms of transformations. So remember, when you have a k value and d value, you have to make sure your k value is factored out. If I factor out a negative, I'm left with x minus 5. So now I can do my sketch. My vertex is the x value is positive 5, and the y value again does not exist, it's 0. So the starting point is over here. But now I have a negative here inside the square root. So if you have a negative inside the square root before the x, it's a reflection in the y-axis. And if you have a negative outside the square root, it's a reflection in the x-axis. So the original graph goes like this way. But if I reflect it in the y-axis, it's going to go like that. If I reflect it in the x-axis, it will be going down instead of up. So now I can do the domain and range of this one. For my domain, my lowest x value is negative infinity, but my highest x value is positive 5. So basically, it's x is less than equal to 5 because x takes every value less than 5. My range, my smallest y value is 0, and my largest y value is positive infinity because this graph will keep going up, doesn't actually become horizontal. It flattens out, but it never becomes horizontal, so it'll keep going up, which means that y is greater than or equal to 0 is my range.